Imagine picking up what looks like an ordinary gray rock. Then, with one small turn in the sunlight, the surface suddenly erupts into brilliant flashes of electric blue, emerald green, fiery orange, and deep violet. Most people would call it opal. But here's the surprise. Some of Earth's most spectacular rainbow minerals aren't opal at all. In fact, several of them are even rarer in nature, and each creates its dazzling colors through a completely different geological process. Once you understand those processes, you'll never look at colorful rocks the same way again. Today, we're exploring 10 extraordinary minerals that can rival the beauty of precious opal. You'll discover where they form, why they display incredible rainbow colors, and the famous locations where geologists and collectors have found some of the world's finest specimens. More importantly, you'll learn the geological clues that help experienced prospectors recognize these remarkable minerals long before their hidden colors become visible. Nature doesn't create rainbow colors by accident. Every flash of blue, every streak of gold, every burst of crimson is the result of millions of years of geological processes. Some minerals bend light through microscopic crystal layers. Others reflect light from ancient biological structures. A few owe their beauty to chemical changes that occur only after reaching Earth's surface. Different origins, different chemistry, yet the same breathtaking result. Let's begin with one of the most famous optical minerals ever discovered: Labradorite. Fresh from an outcrop, Labradorite rarely attracts attention. Its weathered surface is usually dull gray, sometimes almost black. Nothing about it suggests extraordinary value. But break the rock open, or catch a freshly exposed crystal at the right angle, and everything changes. Brilliant sheets of electric blue race across the surface. Emerald green follows. Then flashes of gold, sometimes even violet. This remarkable optical effect is called labradorescence. Unlike precious opal, these colors aren't produced by tiny silica spheres. Instead, they come from microscopic layers inside the feldspar crystal. As light passes through those layers, certain wavelengths reinforce one another, while others cancel out, producing shimmering bands of color that seem to move as the stone turns. Location number 1. Labrador, Canada. The mineral takes its name from the rugged coast of Labrador, Canada, where missionaries first documented it in the late 18th century. The region is dominated by ancient anorthosite formations that cooled slowly deep within Earth's crust. That slow cooling allowed the crystal structure to develop the internal layers responsible for labradorescence. Today, Labrador remains one of the world's classic localities for this remarkable feldspar, and fresh coastal outcrops continue to reveal specimens with spectacular flashes of color. For prospectors, the lesson is simple. Never judge weathered feldspar by its surface. The real beauty may be hidden just beneath it. Rock number 2, Ammolite. Unlike every other mineral on today's list, this rainbow treasure began as a living creature. More than 70 million years ago, giant ammonites drifted through the warm waters of an ancient inland sea that covered much of western North America. When they died, their shells settled into soft marine sediments. Under very unusual geological conditions, the delicate aragonite layers of those shells survived burial instead of dissolving. Over millions of years, pressure preserved the microscopic structure that now reflects brilliant reds, greens, blues, golds, and purples. The result is one of the rarest organic gemstones on Earth. Unlike opal, whose colors come from silica spheres, Ammolite produces its fire through incredibly thin layers within the fossil shell itself. Location number 2, Alberta, Canada. Nearly all commercial Ammolite comes from the Bearpaw Formation in Alberta, Canada. These late Cretaceous marine sediments preserve one of the richest concentrations of fossil ammonites ever discovered. Collectors searching these rocks aren't simply hunting gemstones. They're uncovering pieces of an ancient ocean that disappeared millions of years before humans ever existed. Rock number 3. Bornite, peacock ore. Freshly broken bornite has a metallic bronze color. Nothing more. But exposure to oxygen changes everything. An extremely thin oxidation layer begins forming across its surface. As sunlight reflects through that microscopic film, brilliant blues, purples, greens, and copper-red colors suddenly appear. This spectacular display has earned bornite its popular nickname, peacock ore. Unlike opal or labradorite, however, these rainbow colors exist only on the surface. Scratch away the oxidation layer, and the rainbow disappears. Location number 3. Butte, Montana, USA. One of the world's most famous bornite localities is Butte, Montana. Its historic hydrothermal copper deposits produced enormous quantities of copper sulfide minerals, including bornite. The same geological fluids that transported copper through fractures deep underground eventually crystallized into one of the richest mining districts in North American history. For geologists, colorful bornite isn't just beautiful. It's evidence of a much larger mineralizing system hidden beneath the surface. Rock number 4. Iris agate. Most agates are admired for their beautiful bands. Iris. Agate hides something even more extraordinary. Hold an exceptionally thin slice toward bright sunlight, and brilliant rainbow spectra suddenly emerge across the stone. These colors don't come from pigments. They come from thousands of microscopic silica layers deposited one after another as mineral-rich groundwater slowly filled ancient volcanic cavities. Together, those layers act like a natural diffraction grating, separating white light into every color of the visible spectrum. Location number 4. Graveyard Point, Oregon, USA. Some of the finest iris agates have been collected near Graveyard Point along the Oregon-Idaho border. Millions of years ago, volcanic eruptions blanketed the region in basaltic lava. Gas bubbles trapped within the cooling lava later became cavities, where silica-rich fluids slowly deposited layer after layer of agate. The result is one of the world's finest natural laboratories for studying silica deposition. Rock number 5. Spectrolite. At first glance, spectrolite looks remarkably similar to ordinary labradorite. But when light strikes the crystal, the difference is unmistakable. Instead of displaying only blue and green, spectrolite can reveal nearly the entire visible spectrum: deep crimson, brilliant orange, emerald green, royal blue, violet, sometimes all at once. Its internal crystal structure developed under exceptionally favorable cooling conditions, producing larger and more perfectly aligned reflective layers than ordinary labradorite. Location number 5. Iisalmi, Finland. The world's finest spectrolite comes from Iisalmi in southeastern Finland. These ancient Precambrian rocks were shaped by enormous geological forces over billions of years. Their slow cooling and later metamorphic history produced some of the most colorful feldspar crystals ever discovered. Even today, Finnish spectrolite remains the international standard for this remarkable variety. 5 minerals, 5 different geological origins, ancient fossils, deep igneous intrusions, hydrothermal copper systems, volcanic silica deposits, and billion-year-old crystalline rocks. Each creates rainbow colors through a completely different process. Yet all can be mistaken for precious opal by an untrained eye. That's the beauty of geology. Similar appearances, completely different stories. If you're enjoying uncovering the science behind Earth's most extraordinary minerals, subscribe to Pro Gems. Every week, we explore the geological clues, hidden treasures, and remarkable stories that most people walk right past. Rock number 6, Fire Obsidian. Obsidian is usually known as a jet-black volcanic glass created when silica-rich lava cools so rapidly that crystals never have time to form. Most pieces appear glossy but plain. Occasionally, however, nature produces something extraordinary. Deep beneath the polished black surface, brilliant flashes of emerald green, fiery gold, crimson, and violet seem to ignite as the stone moves. This is fire obsidian. Unlike precious opal, the colors are not created by silica spheres. Instead, they come from microscopic layers of magnetite nanoparticles trapped inside the volcanic glass during cooling. Those ultra-thin layers reflect and interfere with light, creating shimmering colors that appear to float beneath the surface. Location number 6, Glass Buttes, Oregon, USA. The world's finest fire obsidian is found around Glass Buttes in central Oregon. Millions of years ago, volcanic eruptions spread thick rhyolitic lava flows across the region. Rapid cooling created vast deposits of obsidian, but only a tiny fraction developed the internal magnetite layers needed to produce the famous fire effect. Even today, finding high-quality fire obsidian remains exceptionally uncommon. Rock number 7, Rainbow Hematite. Hematite is one of Earth's most common iron minerals. It's usually recognized by its metallic gray appearance and distinctive reddish-brown streak. Yet, under very specific conditions, hematite develops an entirely different personality. Thin oxide films grow naturally across crystal surfaces, producing vivid flashes of blue, purple, green, gold, and red. The colors shift constantly as light strikes the crystal from different angles. Unlike pigments, these brilliant hues are created by optical interference within microscopic surface layers. Nature is literally painting with light. Location number 7, Minas Gerais, Brazil. Some of the finest rainbow hematite specimens come from Minas Gerais, Brazil, one of the world's richest mineral-producing regions. Its ancient iron formations and hydrothermal activity have produced exceptional crystals for generations. For mineral collectors, the region is famous not only for gemstones, but also for museum-quality hematite, displaying spectacular iridescence. Rock number 8, Rainbow Pyrite. Most people know pyrite as fool's gold. Its bright metallic luster has fooled prospectors for centuries. But under the right geological conditions, pyrite can become something completely unexpected. Delicate surface films develop naturally on crystal faces, transforming ordinary golden cubes into dazzling displays of blue, violet, green, orange, and crimson. These colors aren't permanent coatings. They're optical effects created as light reflects through microscopic alteration layers. Because those layers are incredibly thin, even slight weathering can change the appearance over time. Location number 8, Navajoon, Spain. One of the world's most celebrated pyrite localities is Navajoon, Spain. The deposit is famous for producing remarkably perfect cubic pyrite crystals, many with mirror-like faces. While collectors treasure the crystal perfection, certain specimens also display subtle rainbow iridescence that reveals the delicate interaction between mineral chemistry and Earth's atmosphere. Rock number 9, Chalcopyrite. At first glance, chalcopyrite resembles dull brass. Fresh crystals show a rich golden-yellow metallic color, but exposure to air and moisture gradually changes the surface. Microscopic oxidation produces brilliant blues, purples, greens, and reddish tones that seem to flow across the crystal. Because of these striking colors, chalcopyrite is often mistaken for Bornite. Yet the two minerals are chemically different. Experienced geologists distinguish them by hardness, crystal habit, streak, and the surrounding mineral assemblage, not by color alone. It's another reminder that appearance can be deceptive. Location number 9. Cornwall, England. Historic Cornwall is one of the world's classic localities for chalcopyrite. Its extensive hydrothermal copper and tin deposits supplied Europe with metals for centuries. The same mineral-rich fluids that formed those famous ore veins also crystallized beautiful chalcopyrite specimens that remain prized by collectors today. Rock number 10, Moonstone. Unlike the dramatic flashes of metallic minerals, Moonstone offers something quieter. Its light seems to drift beneath the surface like soft blue mist. As the stone moves, subtle flashes of silver, peach, gold, and occasionally rainbow colors glide across the crystal. This optical effect is called adulorescence. It forms when microscopic layers of two feldspar minerals separate during extremely slow cooling deep underground. Instead of reflecting light from the surface, those internal layers scatter it gently, producing the stone's famous floating glow. The result is one of the most elegant optical effects found anywhere in the mineral kingdom. Location number 10, Agate, Sri Lanka. Some of the world's finest moonstones come from Agate, Sri Lanka. For generations, miners have carefully extracted moonstone from narrow underground workings that follow weathered pegmatite bodies. Many of the finest gems display a luminous blue sheen, while the rarest specimens reveal delicate rainbow flashes that rival far more famous gemstones. The deposit remains one of the most important sources of premium moonstone on Earth. From ancient volcanic eruptions in Oregon to billion-year-old iron formations in Brazil, from the perfectly shaped Pyrite crystals of Spain to the historic copper mines of Cornwall and the legendary moonstone deposits of Sri Lanka. Each of these remarkable minerals tells a different chapter of Earth's story. What makes them truly extraordinary isn't simply their beauty, it's the science behind that beauty. Every rainbow you saw today was created by a different geological process. Some formed through microscopic crystal layering, others through thin oxidation films. Some preserved delicate structures inside volcanic glass. Others developed within slowly cooling feldspar crystals over millions of years. That's why experienced prospectors never chase color alone. They study the landscape. They examine the host rock. They understand the mineral associations. And they know that every remarkable discovery begins long before a crystal catches the light. Because in geology, the most valuable tool isn't a hammer, or a shovel, or even luck. It's knowledge. The next time a simple rock flashes with unexpected color beneath the sun, remember this. It may not be precious opal, but it could still be one of nature's rarest masterpieces, waiting for someone who understands the story written inside the stone. Thank you for watching Pro Gems. Until next time, keep exploring, keep questioning, and keep looking closely.